All right, section 2.6, algebra functions. So we're going to leave graphs behind here, and then we'll get back to graphs in section 7. First thing we need is this little bit of notation. It's an upside down U, it means intersection, and really that kind of means overlap. And that's going to be important when we start talking about domain as we put these functions together. It's not a huge concept. You'll be okay probably without it, but just, there it is for you. So we have 4 basic algebra functions that we can do. We can add, subtract, multiply, and divide. I'm going to spend most time here looking at sums and then a little bit more time again when we get to quotients, because really they all basically work the same way. You just change the operation. Instead of adding, you subtract or multiply. All right, so a sum, f plus g of x, please note you could also just write f plus g. It just means the same thing. It means you're going to take the first function f of x and add it to the function g of x. The domain for that, I didn't write down, is the domain of f intersected with the domain of g. So it is the overlap between the domains of the two functions. Basically, you can only use things in the sum that you could use for both of the original functions. And we'll kind of look at that here with this example. So I have f of x is equal to the square root of x and g of x is equal to 3x squared. Importantly, the domain for f of x is only numbers bigger than or equal to 0. For g of x, you can plug anything you want to 3x squared, so it's going to be all real numbers. Now, when I do the sum function, which is its own function, adding these two things together, I'm really just doing f of x plus g of x, so notice what we have here. Here is my f of x. Here is my g of x. Okay, that's what those two pieces are. What don't you see? You don't see another x. For some reason, people always wanted to think of this as multiplying f plus g and then times x. This is just the notation we have for this new function that is adding these two things together. So there isn't any multiplication here with another x. Please don't put that there, but for some reason people like to do that. So just don't, that would be bad. Now the domain for my new function, which is these two functions put together, is the overlap. So you can get away with just most of the time. Every now and then it doesn't work, but most of the time you can just get away with writing out this new function and saying, okay, well now what can't I use? Well, the square root still limits us. You still can't use anything that's negative, so the domain is x has to be bigger than or equal to 0, or an interval notation from 0 to infinity. It does include the 0, okay? You can use 0 here. You just can't use anything negative. And so that's why it's the intersection, because we can still only use the one that's restricting us. That's really what's giving us our domain. And so that's the sum. We're going to look at differences, products, and quotients. We'll take just a little bit more time on again because there's a little quirk there. And yeah, and then we have this other kind of algebra function that we'll look at that's a little bit different and a little bit weird. All right. Okay, so here are the other 3 basic algebra functions that we have to look at. Differences, products, and quotients. So with a difference, it's exactly like addition. It really is, except now you have a minus sign instead of an addition sign. So f minus g of x is equal to f of x minus g of x. Again, don't throw an extra x in there for multiplying. It's not part of it. The domain is still just the overlap between the two functions, so it really is going to look exactly like what we had for the sum, just with a minus sign. And the same is true with the product. F times g, you can either have the f and g smashed together, you can put a little dot in between. We don't use an x, that would be bad, it would get really confusing. This is f of x times g of x, and again, the domain is just the overlap between the two. Now, quotients is where it's going to get just a little bit different, not a lot, just a little bit. F over g of x is f of x over g of x. Okay, you're like, that's exactly what I would have thought. We have one little change down here in the domain. Now the domain is not just the intersection between the two, not just the overlap, but the bottom of your fraction cannot be 0. So for instance, if g of x was x plus 1, you'd have to throw away -1 as part of your domain because you can't have 0 in the denominator. And so that's just one extra thing you'll have to look at if you have the division of functions. Now, what can we do with these? We can write out a sum or difference, kind of like or product or quotient. It's very similar to what we did with the sum, right? I gave you two functions, we added them together, and we said, hey, here's the sum function. We could do that with any of these. We could do it with numbers. Okay? We could take a number and we could plug it in. We could say, hey, find f over g of 2. And then you would just need to find f of 2 for the top, g of 2 for the bottom, and the answer would just be a number then. So anyway, those are your basic algebra functions. We have one more really important one to look at, and it's a little bit different, a little bit weird, so we'll spend a bit of time there. All right, yeah, here we go. All right, last bit here, although I will have to put a little bit more on the board to finish talking about this. Composition functions. Composition is when one function gets stuck inside of the other. Okay, and so I have some examples here that we're going to work through, but one function is stuck inside of the other. This is kind of like an assembly line. A number comes along, it goes into one function, you get an answer, and then the answer goes into the second function. So importantly, I like to rewrite my composition, which we use a circle for. Here I have f circle g of x, again, not times x, okay? Don't throw that extra x in there. And so I like to rewrite it. Notice that the f and the g stay in the same order here in terms of from left to right. And so g is the function, in this case, that is stuck inside of f. Okay, we're going to look at examples where those are both ways, but g here is the function on the inside. So here's an example. F of x is x squared minus 3, and g of x is x plus 5. I want to find f circle g of 3. So the first thing I do is I rewrite it, f, and now I can see g of 3. That's the inside piece here. So I need g of 3. I came over here because I have limited room on my board, and I found g of 3. I plugged in 3, 3 plus 5 gave me 8. And so now g of 3 turns into that 8, and I need to find f of 8. Well, that's just straightforward, plugging in a number into a function. I plug it into f, 8 squared minus 3, and if you trust me, that's 61. But what happens if we turn the order around? What if we do g circle f of 3? The question is, will we get the same number? Will we get 61 again? Well, you can see on my board that we don't get the same number. And, I just turned it around. Now f is the inside function, so I needed f of 3 first. 3 squared is 9 minus 3 gives me 6. G of 6 then, if I plug it in there, gives me the 11. So the order really matters, but it's important to note that from left to right, the order stays the same. G, circle f, G with f on the inside. And so that's how you do this with a number. And in our last example, we'll look at what happens if we just want to do this with the letters. Okay, and so that's what's going to be on the next board. Okay, so as you can see, I kept the same two functions, same f and g. But now I want to do it without any numbers. I just want to put these two things together. I want an equation, an expression for these two functions combined. Okay, and again, order matters. So I want f circle g of x. That means g is on the inside. Well, what are we going to put in there now? In the last two examples, we took a number, or we found out what g of 3 was, and we put that number in there after we got it. So instead, we're just going to take the rule for g, x plus 5, that's way over there, and that's what's going to go inside of f. We take the rule for g, and it gets tucked inside of f. Now, x plus 5 takes the place of the x in f of x. Or if you had several x's, it would take the place of all of them. I expanded my parentheses. Again, be careful. This is not going to be x squared plus 25. You do have to actually multiply this out. If you do, you get x squared plus 10x plus 25. You have that middle term. Don't lose that. So the minus 3, so then I just combine my like terms, and we get x squared plus 10x plus 22. And so that's algebra of functions. It should be good times. I really like it, but I'm kind of a nerd, so maybe I don't count. Anyway, enjoy and good luck.